Assalamualaikum. Good day, everyone. We continue our lesson. We stopped at example 3 in the previous lecture. So we continue on example 4. And this time, we are throwing something upward, but at the edge of a cliff, right? So the difference is, previously we have discussed something that we drop from certain height, something that we throw downward, and then in next question we throw something upward, and this time we are also trying to throw something upward, but we are at the edge of a cliff, such that if you look at the figure on your right hand side, we are throwing something upward, then the object keeps on falling down to the bottom of the cliff. So the difference is our sy is no longer equals to 0. We have so the sy here is negative because fy came from the equation of s equals to ut plus half at squared. So this is the equation. Okay, so our sy is the displacement. So for our ball, for example, we throw ball upward, reach the pinnacle top, where at the pinnacle top the vy equals to 0 because it stops for a while and it goes down back again. So it goes down way back to the bottom of the cliff. So this is our initial position. This is our final position, and looks like our sy or displacement is the shortest distance between the initial position to the final position, and it is going downward. So our sy will be negative. Right? So our pre-assumption, our sy is negative. It's going to be negative, but we just don't know the value yet. So if the question gives you the uy, the initial velocity of the ball is being thrown upward. Okay, we have the initial velocity throwing upward, for example, 15 meters per second. Okay, maybe given to us the depth of the cliff. For example, the question gives you the depth of the cliff, this length. Okay, if the depth of the cliff is given 50 meter, so that means it is our sy, and our sy is negative 50 meter. Why negative? Because it is displacement. We should show the direction. So the direction of sy is the shortest distance from initial position to the final position c. So our sy is negative because downward. Okay, we could take the depth of the cliff becomes our sy. So we could manipulate this one, becomes negative 50 meter. Okay, so this is free fall, even though you're throwing upward, but the ball is being pulled down by the gravitational acceleration, and our ay is still negative 9.81 meter per second square, and this is the gravitational acceleration. So if we have this kind of question, maybe I could ask you the time to reach the base. Right? For example, you throw something upward. I ask you the time taken, the whole flight of the ball to reach the ground over here. I could ask you that question. Okay, question A. Question B, the total distance traveled. Now look very carefully. I'm asking about total distance traveled. It means it is a scalar quantity. So you should add up the first movement from A to B, then the second movement from B to A again, and the third movement from A to C. This is very simple. B is very simple. Just add up all the distances that you know. Now, time to do the hardest part. That is the A part. Okay, time to reach the base. Remember, you need to manipulate the 3 kinematics equations only: Sutat, Vutat, and Vuzas. So trial and error. Use any of the equations until you see the dead end. Then you change to the second formula or the third formula. Right. So it happens to be you could use the Sutat or sy equals to uyt plus half ayt square to calculate the solution for question A. So sy, as I mentioned before, we could manipulate the depth of the cliff becomes our sy. But remember, sy, the ball going downward, so sy our negative. So negative for sy. U is given, u 15 meter per second, u. Okay, t is unknown because we want to calculate t. Half ay. Ay is the gravitational acceleration, negative 9.81 meter per second squared. So it looks like we have a quadratic equation. Use your scientific calculator to calculate the quadratic equations, and you got t equals to 5.08 second. And the other one may be negative 5.08 second, but do not take the negative one because time is a scalar quantity, you mustn't choose the negative value of the t. I believe your calculator will give you two values for t, right? The first one is positive, the second one is a negative. So do not choose the negative one because time is always scalar quantity. All right? Okay, now, easy peasy. Look, B, total distance travel. Oh, all right, total distance travel. The 11.47 is not given. Ini jawapan. I accidentally revealed the jawapan. But anyway, we need to calculate. So from A to B is unknown, B to A is unknown. We only have from A to C. We only have that information. But anyway, we could calculate from A to B. How? Because the movement from A to B at the top of B, our Vy equals to 0. Remember, the ball goes upward and it stops for a while. During the stop, the velocity of the ball is equals to 0. So we know that clue. So at the peak B, Vy equals to 0 meter per second. Now we could use our second equations. Maybe Sutat we have used. How about Vutat? How about Vuzas? So I'm using the Vuzas. V equals Vy square equals to Uy square plus 2Ay Sy. Ataupun V equals to U plus 2As. Simply said just like that. Right? All right. So we have the V. Saya tulis apa tadi? Lupa. V square kan equals to U square plus 2As. Yes. So Vy square, remember Vy square, the velocity over here equals to 0. So easy. So Vy square equals to 0. How about Uy square? Uy square is given from the question, 50 meter per second square. Okay, plus 2As. 2A is the gravitational acceleration and Sy, we could find out the Sy. So we calculate using calculator, you got 11.47 meter. So the distance travel from A to B is 11.47 meter. Same goes from B to A, also 11.47 meter. So from A to C is 50 meter. There you go. You got 11.47 meter plus 11.47 meter plus 50 meter. You got 72.94 meter. Look, again, the question, I asked you about the total distance travel, not the displacement. Because if I ask you the displacement always be this one. That is the Sy equals to negative 50 meter. I asked you about distance travel. The real distance travel, the length of distance travel, which is scalar quantity. So you need to add up from A to B, B to A, and A to C. This is still very, very easy. Now, we have done discussing about the first part of free fall, right? Again, this is just a wrap up of whatever we have learned. We have only three questions. Okay, 3 questions. Vutat, Sutat, Vuzas. Right? Remember, we just need to add the Y component for free fall. Right? Free fall. Why? Free fall is falling downward. It involves only Y-axis. Okay, from Cartesian coordinate, Y-axis is like this. Cartesian coordinate, Y-axis is like this, and X-axis is like this. So for free fall, we only involve the component in Y-axis. It goes up and it goes down. Okay, so that's why we are using the Vy, Uy, Ay, and also Sy. Whether they are negative or positive, going upward positive, going downward negative. That's all. Right. And our Ay is actually because Ay downward. All right, Ay downward. So this will be our G, our gravitational acceleration. The value is negative 9.81 meter per second square. And for my formula, there will be no negative sign over here. All are positive. All are addition, no subtraction. I know that certain classes sometimes they use plus, sometimes they use minus. It's very confusing. People don't know when to use positive, plus or minus. So for my students, always use the addition formula. No negative. The negative one later we will put inside the Ay. Yes, the Ay value is negative 9.81 meter per second square. We will put the negative sign later when we try to plug in the parameters given. Okay, by default, the formula will be always positive. You only put the negative sign only if the value given is negative. That one comes later. Right. So we have done free fall kinematics. So we need to look at the second part, which is very important. Of course, I will ask this question in the test. Of course, definitely. So listen carefully. Wait up. Okay. Now we are looking at projectile motion. This one a bit different. If free fall, the ball goes upward and downward only, right? Upward and downward only. But projectile, the ball goes upward and downward, and also from left to right or from right to left. Look at the animation that I'm showing right now. The ball goes upward and it goes to the right as well. Ball goes upward and downward. That is Y projection, and it also moves from left to the rightward. So that is our X projection. So for projectile motion, it involves combination of X and Y movement. Ball goes up and down, also from left to right. Okay. Now, let me try something else. You can play around, Maybe for those who likes to go fishing or playing football, this angle of launch angle, the launch angle means this angle. This angle is very important. This angle is very important because at certain angle you might get longer projectile motion. For example, if you try to adjust the launch angle, look. If we adjust the look, this is 90 degrees upward. Becomes okay when the angle becomes smaller and smaller and smaller. Let's try to 66 proper. Looks like our range could be maximized. The range of projectile motion could be maximized maybe from the angle around 45 degrees. Okay, even though if we try to change the initial velocity, if we decrease the initial velocity of the projectile motion, of course, the range will become shorter and shorter and shorter. So if we could go as maximum as we could give the initial velocity of the ball could go further by manipulating the projectile angle. Okay, smaller than 45, you will get shorter distance and shorter and shorter and shorter. So if you go exceed 45, the ball also becomes shorter and shorter and shorter. It goes high, but the projectile motion becomes shorter and shorter. So the best way is usually 45 degrees. Nah, bergantung juga arah angin lah. Kalau stadium kamu tu tak ada angin semua, even better lah. You could go further. Ataupun kalau tiba-tiba angin daripada belakang datang bantu kamu, you will go also further. Dan dia akan pergi curve dan sebagainya. Unpredictable ball. Macam Faiz Subri buat because mungkin angin membantu. Yes, angin membantu. The spinning of the ball also will help the projectile motion. But just in case the ball doesn't spin, no wind factor, and you hit the ball straight, there you go. This is the projectile motion of the ball. This is in 2D, by the way. This is not in real situation. This is 2D, X and Y. So in real situation, we need X, Y, also Z, because we are living in three-dimensional space. It will be very, very complicated, right? The wind not just come from the front and the back, up or down. The wind also comes from the sideways as well. Yang tu lebih three-dimensional system lebih complicated, but we are not discussing that in diploma level, right? So one thing you have to remember is that the velocity, the initial velocity or the final velocity, as you can see the component of Vx and Vy. See, it's changing. Look at the blue one. Look at the blue arrow first. Look at the blue arrow. The blue arrow maintain its length. Look carefully. The blue arrow, the Vx, is maintaining its length. Okay, number one. And number two, the blue arrow also maintain its direction, which means always from left to right. See the head of the arrow always pointing rightward. This is a clue. For Vx, the magnitude and the direction doesn't change in projectile motion. If you calculated Vx initially 2 meters per second rightward, it keep on maintaining its magnitude and direction 2 meters per second rightward until the end of the projectile motion. Okay, that's the blue one. How about the y component, the up and down component? Look again, the green arrow. The green arrow changes every time. The first one, it changes the magnitude, the length of the arrow. Okay, look, it changes from big to small, small, zero, and bigger, 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 but the direction also changes. From positive, upward, until the top, it goes downward. That's true, because your ball goes upward first, and at the pinnacle top, it stops for a while, and it goes downward again. See? So that's the movement of from left to right, and from down, up, and down again. That's the movement. The arrow, Vx and Vy, tells you about the movement of the ball. Look very carefully. For those who hasn't taken any physics before, look very carefully. Remember my clue, you will be safe. Right. So now, how can we calculate the initial velocity of the ball? Yes, we could calculate. And we have formula for that. Okay, if we have an angle over here, if we could measure the angle over here, if we could measure the angle over here, let's say we have theta over here, therefore we could calculate the u. How do we calculate the u? It's very easy. At this point, you just need to memorize ux equals to u cos theta. So what is u? U is this one. The initial velocity of the ball after it has been kicked or being launched by somebody. So this is u. How about theta? This is the theta. This is the launch angle, the small pizza over here. This is the theta. So you have u, you have theta. Remember, u is actually a vector quantity. So we must resolve into the uy over here and also ux over here. Remember, you have to resolve the u into ux and uy. This is ux, this is uy. And how to resolve? Look at this equation. Usually, we will use ux equals to u cos theta. Forget about the u naught. I mistyped. It is for other section. They are using u naught very, very hard. Just use u. V is final velocity. U is initial velocity. So what is u? U, any value given over here. Okay. And if you want to solve the projectile motion, first and foremost, if you could see u is given automatically, your first move should be resolve it into ux and also uy. And how to resolve? So ux equals to u cos theta. This one. Ux equals to u cos theta. And how about uy over here? Uy. This is uy. Uy equals to u sine theta. And this is your formula. Right? Maybe some of you has question. So why ux use cos, uy use sine? Well, I'm not showing you over here. Later in the class, I will show you directly how do we get that formula. It's not necessary to understand the derivation, but I will show you why we use cos and sine if you want to, right? So look again, if we have sy and xx over here. So in pre-fall, the previous part, we only play around with uy, vy, ay, and sy. But for free fall, for projectile motion, because the ball is moving up and down, also from left to right, we have both x and y components. So instead of vy, uy, ay, and sy, we also have ux, vx, ax, and also sx. So in projectile motion over here, our xx could be manipulated to calculate the total range of the projectile motion, the total range, the distance that the ball can travel. So this is our sx. And sy also can be manipulated to calculate the maximum height of the ball could reach in projectile motion. So this is sy. SY, up and down, up or down, this is SY, left to right or right to left, this is SX. So we can use both equations. Only 3 kinematic equation involved. We just need to play around with the subscript, whether it's SX or SY, VX or VY, UX or UY, AX or AY. That's all. Still 3 kinematic equation, Wuzas, Wutat, and Sutat. 3 only. You don't have to memorize. Oh, if projectile motion, you have to use SX equals to blah, blah, something. They are actually the same equations. Sutat, Wutat, and Wuzas. You just need to play around with the subscript, whether it is X or SY. That's it. All right. So how about the acceleration? I did mention about VX, VY, UX, UY, SX, SY. How about AX and AY? So in projectile motion, the one that only exists is AY. And AY is our gravitational acceleration. How about for AX? The gravity doesn't affect the axis movement. So AX equals to 0. AX always equals to 0, but because no gravitational acceleration acting on the x-axis. That is why from the simulation, you can see only Vy is changing. Why? Because it is being pulled downward by the gravitational acceleration. Why Vx doesn't change? Because no gravity on the x component. No gravity is pulling to the left or to the right, because gravity always pulling downward. That's why your Vy only change. The Vx doesn't change. Not even the magnitude, not even the direction. Right? So we look at the next one. Yeah, this one. So the vector components of initial velocity. Let's say this is your initial velocity. Kita panjang sikit lah. Ni. Your initial velocity. The one that I have shown to you just now. Dekat slide sebelum ni kan. This one. This one. The UI. This one. The UI. We are learning how to resolve it into UX and also UI. We want to resolve that. So this is how you resolve it. We increase about the angle lah. We leave it 45 degrees. Okay, now let's say our initial velocity is 25 meters per second. How do we get the UI, also the UX? This is you, This is you, the initial velocity. This is you. As I mentioned before, for projectile motion, the first thing that you need to do, if the initial velocity is given, you need to resolve into UX and UI. How do you resolve it? Let's say the angle is 45 degrees over here, let's say. So UX, you have to use the formula of cos. This is U cos theta. UX equals to U cos theta. How about the UI? U sin theta. Simple. U cos theta, you got UX. So U sin theta, you got UI. And hit the calculator, you will get UI equals to 17.7 meter per second. And UX also 17.7 meter per second. Sama. And how about if we change the angle? Change the angle. Berapa? 70. Look again. UX and UI is no longer the same. Because why? Because the angle. Cos 70 and sin 70 will give you different answer. Kalau cos 45 and sin 45, they will give you same answer. Right. So your UI this time is 23.5 meter per second, and your UX becomes 8.6 meter per second. Both are positive. And look again, you calculated positive. Look again at the diagram. Yes, UI is facing upward or positive. UX is going rightward. It is also positive. So this is how you resolve the UX and also UI. This will be your first step. Remember, in projectile motion, this always be your first step. Look, if you have the U, resolve it into UX and UI. So after you have resolved, what else you want to do? So comes the next step. All right. Now we look at the easiest part of projectile motion. This is the most basic projectile motion. Huh? This projectile motion, the ball is already at the top of a cliff. Huh? The ball at the top and edge of a cliff. Right? So the ball is being kicked outward, kicked to the right. The ball is being kicked to the right. It will move to the right, and also it will fall down, moving using this trajectory. So this is also projectile motion, but it is half of the projectile motion. Okay, now look again. The ball is being kicked outward. U, X. This is UX. This is UX. This is already UX because the ball is being kicked rightward. Rightward means it moves to the right. So this is UX. This is not U. This is UX. Why? Because our UI over here is 0. The ball doesn't move up and down. Look again carefully. This image. The ball is being kicked to the right. Kick directly to the right. Not kick with a certain angle. No angle is given over here. If angle is given, your ball will move like this. So for this case, the ball is exactly kick rightward. So dia akan keluar ke kanan dan dia akan ke situ. Macam itulah lebih kurang. The ball akan bergerak gitu. The ball is being kicked rightward and it will fall down to the cliff. So the initial velocity, it is UX, 50 meters per second. And UY equals to 0 for this case because the ball doesn't move up or down initially. After it is being kicked over here, it doesn't move up or down. It moves to the right. Moves to the right and later it will fall down. So only UX is could be seen over here. No UY. So initial height, if the height is given 40 meters, then we know 40 meters is the height of the cliff, from the cliff to the bottom of the cliff. So this one could be manipulated and will become our SY. So our SY will become negative 40 meters because the ball will fall down over here. So this is the initial, this is the final position. So from the Y component, this is the position of the initial and this is the position of the final. So this will be our SY. SY. Not SX. SX yang ni. SX yang ini. SY yang ini. I know that the ball jatuh ke sini. But if you look at from the Y-axis, the location of Y position of the ball is actually over here. So this is our SY. It is negative 40 meter. Ni dia. Negative 40 meter because the ball drop downward. Alright. So let's try to play the animation for a while. Play the animation. Yeah, the ball falls. How about we slow down the animation? Initial velocity, all right. Initial height, tinggi sikit. Play again. Yeah, play. See the ball? Look at the red and green arrow. Look at the red and green arrow. Starting from here, downward, downward, downward. Now look at the length of the green arrow. From small becomes bigger and bigger and bigger and bigger. Green, bigger and bigger and bigger. Now look at this time, look at the red arrow. Red arrow means the X component. See, it maintains its direction and also the magnitude. Because it doesn't being affected by the gravitational pull downward. Only your UX and VX being pulled downward, right? So I could ask you a lot of questions based on this this projectile motion. For example, I could ask you about this thing, things that I could ask you, right? So if I gave you the UX, you could calculate the VX over here, also the VY over here. You could calculate that. How? By manipulating the wuzas, wutat, and sutat. Okay, selalunya kita pakai dua je, wutat dengan sutat. Okay, but just in case, you could also use the wuzas. But sama. Ni butat. Ini pun butat. The only difference is this one is X subscript, this one is Y subscript. Sutat juga ni, sutat juga. But difference is this one X, this one is Y. Same. You don't need to memorize. You just need to memorize sutat, butat, and vuzas. That's all. Right? What else? You need to remember the things, the clue that I have mentioned. Right? Apa lagi? Ada contoh tak? Ada contoh calculations. Okay, we have the example of calculation later. We look at this simulation one by one. Okay, now let's say we have a launch angle. Now we have launch angle. Yang tadi tu tak ada launch angle. The one that I have shown to you, this one is our first projectile motion without launch angle. See over here, there is no launch angle. Ni kat sini tak ada launch angle, no angle. The ball is being kicked outward to the right. Memang it is purely UX only. UY doesn't exist because UY over here equals to 0 because the ball doesn't move up and down initially after being kicked over here. So now we are looking at the second part, the full complete projectile motion with launch angle. And what is the launch angle? The small pizza over here is our launch angle. Ini theta. This is the theta. This is the theta. Theta. All right. Now let us try to set launch angle 45, animation speed kita letak slow sikit. Oops. Letaklah 0.3. All right. Now initial velocity 30 meter per second. Now we have the U, and remember, if you were given the U, it means we have U over here, and we need to resolve into UX and UY. How? UX equals to U cos theta, UY equals to U sin theta. You need to calculate UX and UY first. So after you have calculated that one, then look at the question. What are the things that you need to calculate? Right. So if U is given, launch angle is given, you could calculate the UX and UY. And after that, I could ask you to calculate the SY. This is SY. And also, so if you want to calculate the SY, make sure your VY over here equals to 0. Why? Because the ball will go upward, and stop for a while. It stops from moving upward. It stops from moving upward. It changes its velocity to downward. During this stop, our VY over here is equals to 0. You could manipulate that to calculate the SY. How? SY. Yeah. UYT plus half AYT squared. So you have the UY over here. The UY over here can use this one, the one that you have calculated over here. UY over here can be calculated using this one. Masukkan whatever UI that you have calculated before. UI equals to U sin theta. Masukkan dekat sini. T depending on the time that the time taken over here, depending. Okay. Kalau time tak beri kat sini, therefore you need to find the time first. Maybe you could use the VY equals to UI AYT. And if you have the VY which is equals to 0 kat sini, VY equals to 0, and UI, you could use this UI, and AY will be our gravitational acceleration, negative 9.81 meter per second square. And you could find the T, the time over here. And that T, you could use again back to the Sutat equation. Then you can get your SY over here. You have to play around with the equations. If you see dead end, change to some other equations until you could find something that could be used in any other equations. Sutat, Vutat, Vuzas, play around. Sometimes there will be the right solution. Sometimes you need to change the formula 1 or 2 times, right? Sometimes you could use the Vutat, find T first and use T in Sutat, and then you could calculate the SY. Or maybe I could ask you the SX over here, SX. So this is the SX, the range of the ball move to the right. So SX, we need to use the Sutat formula or the Vuzas formula. But instead of using SY, we need to use the SX. So if we want to use the SX, our UX, Our U also need to use UX. Our A also need to use the AY. This will be very, very easy because UX can be used can use the UX that you have calculated over here, which is U cos theta. Huh. How about AX, sir? AX is very easy. AX is equals to 0 all the time in projectile motion because there is no gravitational acceleration on the X component. Gravitational acceleration only acting on the AY. AX is 0. So therefore, half AY t square will become 0. That will be very easy. So our equation for SX is actually SX equals to UX plus T only because half AX t square will become 0. Why? Because no gravitational acceleration acting on the X axis. So X, we can calculate X by UX times T. We know the T, we know T over here, then we could get the T over here. So let's say the ball goes upward until over here and the T is 12 seconds. Ini baru half of the projectile. So another half times 2. 12 times 2, you get 24. So you put 24 over here. 24 times UX, which you can get from here. As simple as that, right? So play around with the animation or the simulation. Play around. Make sure you try to calculate all these parameters using your own initiative. I don't put any questions over here so that you could play around. You try to calculate the Vx, the Vy, okay, from these equations. Play around. Make sure you got this one. Okay, and also you could calculate this one. All right? Try to play around with different T, different V, different S. You could get, if you master this one, you could see that the test question is actually very, very simple. Please do exercises using your own time. I don't provide any exercises, but from this simulation, you could do the calculation at your own time, right? Okay, now, this is also the calculator, quite similar from that of the previous slide. Okay, this is interactive projectile calculator, but do not bring along your laptop or your phone at the test apa ni dewan test center or the atau letak kat tandas, janganlah. If get caught, you could get apa ni, your result will be automatically fail and maybe you will get suspended for 1 semester. Do not tiru-tiru lah. Okay, whatever it is, kita mencari keberkatan lah kan, mencari keberkatan. If we don't know, then we have to admit that we don't know. That's all, right? Kalau tak nanti, kalau yalah, okay, keberkatan ni mungkin you tak berapa faham sampai buat masa ni lah kan. Kalau gaji kita tak berkat, for those who are Muslim, we know the concept of keberkatan kan. If we get the result by cheating and from based on that result, maybe you get promoted or you get hired at certain places just because you got that CGPA or you got A or B in certain subjects, and you, because of that, you got promoted, you got hired, and think about the salary that you receive. Is it halal? Is it shubha? Is it haram? I don't know. You think. Go and ask from the ustaz. Take advice from them. Right. Anyway, if you want to prepare yourself, not during the exam, but before the exam, because test is a test. Test, ujian. Just like our lives in this world, this is a test. We shouldn't cheat during the test, right? The test happened over here. The test is happening during our life in this earth. So after our death, there will be no other test. The marks already taken by the angels. So we're just waiting for the final results. So if fail, we go straight to the that unwanted place. If we pass, we go to the most long place by every humankind, right? So look again, play around with the initial velocity, and play around to increase or decrease. If we increase, all right. So if we the launch angle, if we keep on increasing the launch angle, what will happen? See, you could play around with this one. Initial height, you could change the initial height. For example, if you are at the edge of a cliff and you give launch angle, ataupun you don't give any launch angle. See, this looks like our first case that we have discussed just now. The first case, we are on the cliff, we are kicking something rightward, it goes to the right a little bit, then it goes down. This no launch angle. But what happens if we put launch angle? See, we are on the cliff, we are kicking something, but not to the right, but we have a little bit of launch angle. So this is how the ball will go. So similarly, you could calculate the range. The range means from here to there. This is the range. This is the x-axis. This is the initial position on x-axis. This is the final position of x-axis. So the range is x-axis, the shortest distance from the initial and final position of x-axis. So this is our x-axis. So our x-axis equals to ux t. That's it. From this one, mana ni? Nah, from this one. From this one, sx equals to uxt plus half axt squared, and ax is 0, therefore half axt squared will become 0, and our equation actually only sx equals to uxt. So we could calculate the range of the ball being kicked using the sx. Sx equals to uxt. So how to calculate ux? Simple. You have the u over here, ux is over here, and ux could be calculated using ux equals to u cos theta. That's all. How about uy? Uy over here. Yeah, uy can be calculated using u sine theta. Right? So play around with this one. The initial velocity, launch angle, the initial height, using these equations. Try to find the sx, try to find the maximum height. This is maximum height means sy. Maximum height means sy. This is sy, this is sx. This is time of flight. Time of flight, the whole flight from initial to final over here. Or you could use half of the flight kat sini, time. So over here at the pinnacle top, our vy always equals to 0. Kat sini, pinnacle top. Remember, projectile motion, pinnacle top, vy equals to 0. Remember that. So that's why we could calculate sy over here. Dengan syarat vy sama dengan kosong. Dekat sini, dekat pinnacle top. Alright. So I have mentioned all the clues and parameters. So let's try to look at the example number 5. Motorcycle off a cliff. Sekejap saya tengok. Masih merakam lagi tak ni? Kadang dia stop sendiri ni. Okay, masih merakam. Good. Alright. Now look at the motorcycle off a cliff. So somebody lah, dare enough kan untuk naik motosikal, lompat kat cliff. Dia bukan lompat je. So there is no ramp. Look, there is no ramp over here. Tak ada ramp pun. Tak ada ramp. Yang mana kalau ada ramp, motosikal akan lompat ke sana, naik atas, baru diturunkan. No, this one doesn't have any ramp. Motosikal dia akan bergerak ke kanan dan dia terus jatuh ke bawah begitu. So if you could see the Hollywood, sometimes dia tunjuk scene tu tak berapa logik lah. Car launch from a cliff straight to the right. Tapi kita tengok kereta tu dia bukan pergi terus ke kanan dan jatuh ke bawah. Dia pergi naik atas dulu. Wow, that is impossible. Unless you have a ramp. Kalau ada ramp, dia akan launch ke atas baru dia pergi ke bawah. Sometimes Hollywood ni kena tengok jugalah. Tak logik. Banyak kan tak logik lah. Dia just nak buat kereta lompat ke atas, nampak lebih cinematic. But instead, if you go straight off a cliff, dia akan terus ke depan dan jatuh ke bawah begitu. That's the logic one. So itu dia nampak macam ini, tu nampak macam ini, terus jatuh ke bawah. Alright, so if we have this kind of situation, look again. The depth of the cliff has been given. Kat sini, depth of the cliff 50 meter. That's why this could be denoted as our sy. Sy dia akan turun ke bawah. It is negative 50 meter. See over here, sy 50 meter. And given the sx, okay, the range of the car is 90 meter. Maksudnya, this is the sx. This is the sx. The car falls down, and also the car, car pula. The motorcycle falls down, and also the motorcycle also goes to the right. So it falls down about negative 50 meter, and it goes to the right about 90 meter. But dia ke depan, dia masih ke depan, tapi dia juga jatuh ke bawah, kan? So this is the SY and this is the SX. So the SY is given negative 50 meter, SX is positive 90 meter. Why positive, sir? Because the motorcycle falls down. Yeah, the motorcycle falls down. The one that is negative is our SY. But our SX is positive because the motorcycle fall down and move to the right. The one that fall down is denoted over here, SY negative. SX positive because it also moves to the right. That's why it is positive. Okay, what else? Apa lagi yang saya tertinggal? AY. AY is our gravitational acceleration, negative 9.81 meter per second square. AX is 0 because no gravitational acceleration acting on the y-axis or x-axis or x component. So let's see. Let's say oh yeah, one more thing. Ni tertinggal. UI is 0 meter per second. Why? Because the motorcycle moves rightward. The motorcycle only moves rightward. Nobody tried to push or to give extra velocity of the motorcycle downward. So UI is 0 meter per second. UI. The only thing that we have here is UX. But we want to calculate that. So we need to calculate the takeoff speed, which is our UX. Remember, speed. And initial horizontal velocity UX. We want to calculate that. We have two questions. So the equations always sutat, butat, buzas. Saya tak listkan semua ni. Saya cuma listkan yang the most important thing saja untuk kita punya soalan ni. Right? Sutat, butat, buzas. The same three kinematics equations, the most powerful three equations. So step 1, find the time of flight. Maybe you could find the time of flight. Dia gini, trial and error. Try using butat, buzas, and sutat. So if you use sutat, try to solve something, which is maybe we don't have any clue. Okay, using sutat, what can we accomplish? Try to figure out. SY. We got SY, negative 50 meter. How about UI? UI is 0 because the motorcycle only moves to the rightward. Dia punya initial velocity sebelum dia jatuh ke bawah, dia bergerak ke kanan, initial velocity. Motorcycle tidak bergerak ke bawah, right? Pada permulaan. So it is 0 lah, 0. T, we don't know T. Okay? Half. AY. Remember, this is SY. That's why AY kita pakai negative 9.81 meter per second square. And we also don't know the value of T. And mind, hit the calculator, you got this quadratic equation. And the quadratic equation, you got your time is actually equals to 3.19 seconds. Remember, if you got negative and positive value of time, always choose the positive one. If you got two positive value, then take both. If using the quadratic equation, you got two positive values of T, take both. If you get one, just choose the positive one. Right? So time taken is 3.19 seconds. Okay, now what can we do using this information? So the time taken for the motorcycle to hit the ground is about 3.19 seconds. So what can we do? Try to use some other information pula. Okay, so you have used the SY. Why don't I try to use the SX? So SX equals to UXT plus half AXT square, and half AXT square equals to 0 because AX equals to 0. Because no gravitational acceleration on the x-axis. So our formula only SX equals to UXT. So SX we got over here 90 meter. How about UX? We don't know UX. We don't know and we want to find out. And we don't know, but we want to find out. This could be our solution. How about T? Yes, T is 3.19 seconds. So we could get our value of UX. Therefore, see, UX, we got 28.2 meter per second. And therefore, this is our UX, And also this our take off speed. Dia dah tulis positif kan sebab dia bergerak kanan, dan kita boleh pakai 28.2 adalah kita punya take off speed. Maksudnya kat sini, speed kat sini. This is the speed, this is also the velocity. Same. Alright. What else? Example 6A and 6B, football kick at angle. Kita football kick pula kan. Alright. Macam biasalah, football is being kicked. Alright, so ini kita punya U, ada angle 37. This is our SY, this is our SX. At pinnacle top over here, our V, at pinnacle top, at the top, top over here, our VY equals to 0. Okay, remember. Now, if U is given, you could calculate UX and also UY. Calculate that first, right? So, U is given 20 meter per second, angle is given 37 degrees. So, you could calculate UX using U cos theta. You got 15.97 meter per second. And how about UY? You could calculate using U sin theta, right? You got 12.04 meter per second. And AY, always the gravitational acceleration, 9.81 meter per second squared. Now, we are ready. We have our bullets ready. Now, you could try to solve any questions given. Now, our question number 1, A, the maximum height, SY at peak. This is super easy. This is SY. Remember, at SY, our VY equals to 0. We already remember that. Equations, we have Vuza, Sutat, and Vutat. So, at maximum height, remember, at peak, VY should be 0. So we could use any of the equations that we know. Trial and error. There's no specific tips for you. You should use this one or that one for these cases, but you should do trial and error. So for my case over here, I use the Vuzas. You could try Sutat and Vutat as well until you find dead end, then you change to other equations. So I use Vuzas. So this is VY. VY at pinnacle top is 0. Okay. This is U squared. U squared can be calculated. You can use the UI over here, which we have calculated. And 2AS. 2AS is very simple. A is AY. That is the gravitational acceleration. Negative 9.81 meter per second squared. And SY, we need to know that. SY, this is the one that we are calculating. So manipulate the formula, you got SY 7.39 meters. So this is our SY. Super easy. And how about time of flight? Time of flight, you could use this equation as well. Yeah. You could this equation as well. And the solution, this one of the option, this one of the options. Okay, you could use the Sutat. This is S UT plus half AT squared. We could use the SY. This is the initial position of the ball. This is the final position of the ball. So our SY is 0. Why? Because the ball moves upward, the ball moves upward, and the ball moves downward. So from the x-axis point of view, you are not moving. The same at y position at y equals to 0, and the same y position at y equals to 0. So our SY over here, from here to there, our SY equals to 0. We could use that. So Sutat, the SY equals to 0 because the ball moves upward and downward again, back to the location of y equals to 0. So SY equals to 0. This is UY. UY from the calculations over here. This is UY. T, we don't know T. We want to calculate half AY T squared. AY is gravitational acceleration. And you got this quadratic formula. Use your calculator. You got finally your T is 2.45 seconds. That is time of flight. Or from SY, you could use the equation of Vutat. V equals to U plus AT. t. V equals to U plus AT. You could use that one because we could get V. What else? V over here, V over here, V over here. We know the V over here, Vy over here equals to 0. So if you have Vy equals to 0, equals to Uy could be calculated from here, plus Ayt. This is gravitational acceleration. You could get T. See, you have two equations that could solve your problem for B, whether it is Sutad or the Vutad. You could solve it, right? Next. What else? 1, 2, 3. Two more slides to go. Two more slides to go. Bear with me. Bear with me. All right. Now, I think I won't be recording for example 6A, 6B, and also 6C and D because this is very, very simple. Also, the example 7, I don't think I need to explain to you. I ask you to try to solve, try to think. Promise me you will open these PowerPoint slides and try to do these examples using your own time. Promise me, I won't record this session because it is quite similar to that of the previous examples. So that is all for today. So I wish you all the best for your test on 17th of April. And of course, I will ask you lots of questions with the topics that we have covered before. So class dismissed. All the best.